Welcome to the second video. We're going to start off with another kind of review question, you could say. We're going to be thinking about an angle in standard position. That means it starts along the x-axis, and then the terminal side, I really should say terminal side right here, I believe, contains the point 3, 4. So where it ends, where this angle ends, it's going to go through the point 3, 4. And we also know it's going to be an acute angle. That just means it's going to be less than 90 degrees. Kind of plays a role later in this particular lesson. So again, I would start by drawing a picture. Let's say that we start with a coordinate plane here. And because it ends at 3, 4, I'm just mainly going to draw the first quadrant. 3, 4, let's pretend that 3, 4, that point is something like that. So we have an angle that goes through that point right there. Let me highlight that. That was 3, 4, remember. And the other part of the angle, just based on standard position, has to go along the x-axis. Okay, so that's kind of our picture. I don't know, we don't really care where these rays end so much. Really, they go on forever. But because I know things end at 3, 4, I'm going to use that point to make my right triangle. And I should point out a second that I put a little hint in here in your notes. Whenever we're doing questions like this, basically I want you to remember to always draw a line to the x-axis. So I just drew that line straight down to the x-axis right there. That is basically the way that we read these angles, that we read how we make our triangles, and how we are then able to put side lengths in the pictures. So if you can remember to always draw a line straight to the x-axis, you'll be in really good shape for this. Okay, so this point was 3, 4. So that means, switching colors here a second, that this bottom length would be 3. This vertical length would be 4. And then if we recognize a 3, 4, 5 right triangle, that means that, that the hypotenuse would have to be 5. Okay, so very quickly then, all we need to do is find sine and cosine of that angle. Maybe I should draw that in there too, that the angle is right there. There's theta. So sine of that angle is opposite over hypotenuse. Sine of theta would equal 4 over 5. Cosine of theta is 3 over 5. Okay, and that's, to a certain degree, that's review. We've been doing that for a bit. Let's see how we switch things just a little bit in example 2. So example 2 says much of the same things. It says now theta could be any angle, not just an acute angle, so it could be any angle. And now the terminal, and again that should say side, the terminal side contains the point -3, 4. So our picture will look a little bit different for this one. Again, just switching up colors here. Oops, let me undo that a second. Go get a pen. Okay. So now the point -3, 4 is going to be a little bit more over here, we'll say. So we're still in standard position. So one ray goes like this, and one ray goes up like that. Technically, this angle right here, that's the theta that we're talking about right now. And so you got to follow along here a little bit. And some of this will become clearer in future units. But for now, just kind of trust me on a few things. We're going to do the same method. From that point, -3, 4, I'm going to draw a line straight to the x-axis. And I'm going to use the right triangle that was formed. So if I highlight this a second, this right triangle, I'm going to be talking about that. So I want you to think about what side lengths do I have. Okay, I have purple up here again. Because it's going through -3, 4, I know that this length here is 3, but I'm actually going to consider it being -3. And that's going to be critical down the road. This is going to be 4. And again, if we went through and we did a 3, 4, 5 right triangle, we have a lot of the same numbers as example 1. Now that negative symbol is important. Normally with distance we don't include negative, but because I do, I'm now allowed to say that the angle that I wanted to talk about right here, which was theta, instead of using that angle, I can talk about this angle right there. That's going to be the theta that I use. And so now one side of my right triangle is going to be -3, but by doing that, I'm allowed to say that this is theta. In the video, I'm not going to get too much into the details there. Feel free to jot down a question if that doesn't seem okay to you. If you want a little bit more explanation, we can talk in class. I'm just going to go with it right now. I want you to trust me, but feel free to ask questions in class and we can talk about it a little bit more there. Okay, so from this triangle, find sine of theta. So sine of theta, remember it's the purple theta. So sine of theta is still 4/5, same as our last one. Okay, but cosine of theta is going to be a little bit different. Cosine of theta, adjacent over hypotenuse. The adjacent side is now -3/5. And this is the first example we've seen where a trig idea can be negative. And so that's kind of the new part in this particular video, is that now we can have trig ideas that can be negative, that can be really formed in different parts of the coordinate plane. They can be in different quadrants. And so I think a few key things to take away is that you can have negative sides on your triangle, and that you can, as long as you remember to draw a line straight to the x-axis, that is a key part of solving these kind of questions. Jot down some things that you want to talk more about or any questions that you have. We'll see you in class.